Welcome to this overview and concept of operation for Load Injector. Load Injector allows you to create and inject messages into systems. Load Injector can be used to provide load for system performance and stress testing, simulate operations for quality assurance and acceptance testing, provide a repeatable workload for regression testing, drive different scenarios for training purposes, integration testing, and other scenarios where you want to interact with a message or database-based system. Load Injector runs on a Windows workstation to create and inject load. Its execution can be coordinated across multiple workstations. Overall concept. In Load Injector, one or more sources of data are defined. The types of data that Load Injector can use as source data are 1. Comma-separated variable. 2. XML. 3. Microsoft Excel. 4. JSON. 5. Databases, in particular, MS SQL, MySQL and Oracle. And 6. CETA AMS. As well as defining the data, the source also defines when to fire triggering events. Load Injector can fire triggering events at either a fixed rate, or at a specific time defined by the content of the data. When firing events based on the data content, the time can be either absolute or relative to the start of the execution. One or more destinations subscribe to the triggering events. The destination uses the data from the event to construct a message by substituting data from the event into a template file. The template file is a plain text document which contains textual tokens. The tokens in the template file are replaced each iteration by the defined data supplied in the triggering event or constructed data. Constructed data comprises of types such as unique IDs, random times, random number from a range, items from a supplied list and others. Any variable can be used as a key to look up another variable, which is then substituted into the template file. The constructed message is then sent to a defined endpoint. Currently, 19 different types of endpoint types are available. Load Injector has two main windows. 1. The configuration window, where the configuration is edited, and 2. The execution window, where the configuration is executed. Let's walk through a simple example. First, we'll open an existing configuration file. This example has 3 data sources. The first source is an Excel data source that uses the data in the Excel source to determine when to send the message. Column B in the Excel spreadsheet is defined as the column containing the time element to base triggers on. 3 triggers are defined relative to the time element. The second data source is a rate-based source of flights from AMS. During the preparation phase, flights will be collected from AMS and then sent at the configured rate. The third data source is a rate-based source of data from a JSON file. All rate-based data sources can only define a single trigger. 4 destinations are defined. The first destination is a text window that subscribes to the triggers emitted by the Excel data source. The second destination also triggers off of the Excel data source, but, in this case, the output is sent to a file. The third destination is again a text window that, in this case, uses the data from the flights retrieved from AMS. The final destination listens to the triggers from the rate-driven JSON source. This example uses a number of the text window destination type to make it easy to visualize, but please remember, there are 19 different destination types Load Injector can send to. To run the example, select Execute from the top menu to open the execution window. The Monitor tab is divided into 2 halves. The top half shows the configured sources. The bottom half shows the configured destinations. When Prepare is selected, the view is switched to the Output tab. During the Prepare phase, the triggering events are determined and, since this configuration uses flight data from AMS, the flights are retrieved from AMS. Selecting Execute begins the execution. During execution, the Monitor tab shows statistics for the messages generated and sent. The Scheduled Triggers tab shows the triggers that will be fired from the data-driven sources. The Fired Triggers tab shows the triggers that have already been fired, and the Output tab shows execution messages. Since we have configured text window destination types, we can see the generated messages in Windows. The execution will continue to run until 1. The configured execution time is completed. 2. There is no further source data available, or 3. Until the execution is manually stopped.